Equations with radical expressions. To solve these, you have 3 steps. The first one is to isolate the radical term. So for example 1, it would be this whole a plus 5 underneath the radical. Step B is going to be to square both sides of the equal sign. That's because you want to get rid of the radical sign, so the opposite of rooting is exponent. So this radical sign means to square root, so the opposite of square rooting is squaring that function. And step C is to solve for the variable. So we have 4 examples, as you can see, that we're going to work through. First one, it says the first thing you need to do is isolate the radical term. So if I want to get this piece by itself, I would have to subtract my 7 from both sides, just like you would a normal equation. So I'm left with the radical a plus 5 is equal 12 minus 7 is going to give me 5. Step B says to square both sides of the equal sign. So when I square this and I square this, because remember what you do to one side you have to do to the other, I'm left with just a plus 5. So when you square it, the radical sign goes away, and this is going to equal 25. And now step C says to solve for the variable. So if I want to get a by itself, I'm going to have to subtract 5 from both sides. So I get a is equal to 20. I'm going to do example 2 last because it's the most complicated, so we're going to jump down to example 3 and 4 first. So if we look at example 3, again, we have to isolate that radical term. So right now the 2 in front of it is part of that term. So I would need to add 8 to both sides first. So I get 2 radical x minus 11 is equal to 12. Right now it's telling you to multiply 2 to that radical. So the opposite of multiplying by 2 is going to be to divide by 2. When I divide both sides by 2, I'm left with radical x minus 11 is equal to 6. Now, step B says to square both sides of the equal sign. So when I square this and I square the 6, I get x minus 11 is going to equal 36. And step C says to solve for the variable. So if I want x, I have to add 11 to both sides. So my x is going to equal 47. For example 4, I have the radical already by itself. So the first thing I'm going to do then is just to square both pieces. So when I square both pieces, I'm left with 5x squared minus 9 is equal to 4x squared. Remember that exponent applies to both pieces inside of my parenthesis. So now it's solving for the variable. So I have one constant here. If I want to get that one constant by itself, I would have to move this 5x squared over to the 4x squared. So I'm going to subtract 5x squared from both sides. So when I subtract my 5x squared, I have a negative 9 is going to equal 4 minus 5 is negative x squared. Get rid of my negative sign, so I just changed both of them. So now I have a positive 9 equals x squared. If you look at this, I have x squared. We said the opposite of a radical, so the opposite of square rooting is squaring, which means the opposite of squaring x would be square rooting. So now I would have to square root on both sides. So x is going to simply equal 3, or x equals 3. Remember, these two mean the exact same. Usually your variable gets written first. Now let's go back up to example 2. Again, my radical's already by itself, so I'm going to square both sides. on the right side, I'm left with just x minus 1. On the left side, however, I have x minus 3 times x minus 3. I have 2 of this exact same piece. So when I do my FOIL method, first, outer, inner, and last, I end up with x squared minus 3x minus 3x plus 9 is equal to x minus 1. So now when I combine my terms, I have x squared minus 6x plus 9 is equal to x minus 1. In order to solve this, I need to set it equal to 0. So I would need to move both of these pieces over. So when I subtract x and I add 1, I get x squared minus 7x plus 10. Now we solve this by doing our factoring. So two numbers that multiply to give you 10, that add to give you a negative 7, are going to be x minus 5 and x minus 2. So your options are either going to have to be x equals 5 or x is equal to a positive 2. In order to solve this, we would have to plug in both pieces into our equation to see if it forms a true statement. So if we start with the 5, if I write it over here, I have 5 minus 3 is equal to the square root of 5 minus 1. So I know that 5 minus 3 is equal to 2. 5 minus 1 is the square root of 4, so we get 2 is equal, 2 is equal to 2. Let me rewrite that. So this is a true statement. Therefore, 5 has to be our actual answer. If I plugged in the 2, just to show you, I'm going to do it over here, I would have 2 minus 3 is equal to the square root of 2 minus 1. 2 minus 3 is negative 1 equals the square root of 1. We know that a square root cannot equal a positive or cannot equal a negative. Therefore, this answer can't happen. So again, your answer for this problem would have to be x is equal to 5.